Can you see this? What I shared? Can you see the SPSS software? You just tell me. Can you see screen? You just unmute.
Yes, sir.
Yes. So see, the simple example I have taken. What I have explained in my talk. This is these variables are involved here. This blood pressure, age, obesity, under obesity. This is the BMI index is there. This body mass index. If body mass index is a there is a some measures are there. If body mass index is greater than in a 23 or 26, it's a overweight, and this their definitions are given. I'm not going to into that. So now sugar level, triglyceride. So these few variables I have taken to understand the model, multiple linear regression model. Now here see, this blood pressure is outcome variable. Blood pressure is Y, and this age, obesity, sugar level, and triglyceride. Uh, these are the independent variables x1, x2 up to xk variables. So these are four variables are here. 1, 2, 3, 4. Actually, this is a guess. The last variable is a coronary heart disease, where whether a particular person is a suffered from uh, this heart attack or not, yes or no. Like this is a binary type, but that I am not involving here, because this is one of the outcome, coronary heart disease. But here we have taken, if somebody is suffered from blood pressure. So we try to go back to the past uh, and collect some history of that particular person. What is his age? What is a body mass index? Sugar level, triglyceride. So really, we are trying to find out really these variables are related with the blood pressure, related with the blood pressure. So we that actually see this age, obesity, sugar level, triglyceride, or some other variables you can take as a guess, because this is in your minds. This could be a one kind of a relationship with the blood pressure. Other variable, cholesterol, you can take some. So or sleeping condition you can take. Sleeping, how many hours sleeps or how many hours get sleep. That could be one of the reason blood pressure. Whether alcohol consuming or not, whether smoking or not, that particular person, that could be a reason. Your working condition, how many hours sitting in a in your room for research, that could be a relationship with the blood pressure. So these all are our guesses. If this variable can be correlated, it can be correlated with the blood pressure. That is our guess. But this is a guess. Now we try to find out with the help of some using statistical model. Now question is this, then which statistical model is appropriate? Now your research question is this here. For example, your research question is this: to study the relationship between blood pressure and their risk factors. Blood pressure and risk factor. So what are the risk factors behind this blood pressure? That is our research question. And we are trying to find out the answer of this research question. So which are these variables? Now, if you have taken 10 variables, not all variables are significant. Few variables. If you have 10 variables, there may be a two variables or three variables or one variable may be correlated with blood pressure. But uh, you must know what kinds of methods are available to find out or to give this answer to such kinds of research question. That is so our research question is, or objective, we can say objective, to study the relationship between blood pressure and risk factors. Risk factor is this age, obesity, sugar level, and triglyceride. These are the risk factor. Now, so which model is better? So see, now in a multiple linear regression, there should be a, because I told you yesterday, this all the models are developed on the basis of their scale of measurement that you keep in your mind while choosing the model. Because here is a blood pressure. Now blood pressure is a continuous variable because these are given in number. This is continuous variable, means a variable x which can take any value in an interval. So here blood pressure is a quantitative variable. So this is a continuous variable, and in multiple linear regression also your dependent variable should be measured on continuous scale. Always your dependent variable should be measured on continuous scale, and this independent variable can be measured on continuous as well as uh, categorical scale. There is no issue, and these variables are fixed. Only this blood pressure is a variable, and this other age, obesity, sugar level, and triglyceride, these variables in multiple linear regression we call as a fixed variables. Fixed variables. Now, first question is this. See, yesterday we have seen, we have calculated the relationship, correlation between Pearson product correlation. Why use, now here we can use Pearson product correlation because why? These all the variables are continuous type variables. So here, see, first I will try to find out the whether there is a correlation or not between these variables. So first find out the correlation. This is bivariate correlation. This is, you check out this, you take this, select this all the variables, this all the variables with, and drag here in variable list box, and this Pearson is a click. Now you just click OK. Now click OK. This is, so this correlation matrix you will get. Correlation matrix. Now you look at the correlation matrix. Now here, this is a blood pressure. You look at the first row. Blood pressure. This is a blood pressure. See, this 1111 means this is the variance values. This is variance values because this is a correlation matrix, and off-diagonal elements are correlations, R values. This is, now blood pressure and age, there is a correlation. This is R equal to 0.664. But obesity has more correlation. Obesity, this obesity is a more correlated with blood pressure. If you have, if somebody having a obesity, so definitely there may be a chance to suffer from blood pressure. That it might be that particular person. The data shows here. Data shows here because it's a large correlation with obesity and blood pressure, and then what sugar level, triglyceride. These are that much not correlated with blood pressure, but there should not be correlation with within this variable: age, obesity, sugar level, and triglyceride. So you can check here this age. Age is not that much correlated. So age and obesity, there is a some correlation, but then other variables are not that much correlated. This is, so now after only this is an indication. If there is a more correlation between blood pressure and your independent variables, it indicates that that variable is making role to predict the blood pressure, that variable. Now here is a obesity is a higher correlation with blood pressure. So definitely obesity is one of the risk factor of blood pressure according to this data set. But still we have not seen whether this significant or not. This is a only on the basis of correlation we cannot say whether this particular variable is a significant or not, because all variables are involved here when one variable is involved, because age and obesity and sugar level and triglyceride all are together that variable. So we have to test them, because if one variable is involved there, so it will be affect together. So see here, now I'm just performing now that regression. Now here regression option is here, regression. And in a regression, this linear, click on a linear. When you click on a linear, this dialog box will open. Now here, this dependent two boxes here, dependent list box and independent list box. This is a dependent variable. Here is a, your dependent variable is a blood pressure. You drag in a dependent variable box. And these other variables, this age, obesity, sugar level, triglyceride, you drag in a independent variables. Here is independent variables. Now you don't do anything. Now just click over here. Click over here. See, automatically this outcome will be shown in outcome window. This is outcome window. Now question is this, how to interpret this? How to interpret this result? See, you look at this model summary is a fun in first table. This is a model summary is a, this is a R square values. Your R square value is a 0.683 R square value. So it indicates that this R square is a, see, I told you this R square is a lies between 0 and 1. If R square is a very nearest to 1, it indicates that our model is good fit. And R square equal to also we can conclude, so how much percentage, how much proportion of variance of dependent variable explained by independent variable, explained by independent variable. So here this R square is getting 0.683. This indicate that 68.3% of variance of dependent variable is explained by independent variable. These four independent variables explained by. And see, in a theory, in a slide, in a theory, I shown you one ANOVA table, and this is ANOVA table. This is ANOVA table. In a slide, I shown you this ANOVA table, this regression, sum of square, and then now variables are, independent variables are 4. That's why it is 4. This mean square is calculated here by software. This residual also calculated by software. And here is a F value. This is a mean square regression. Actually, this mean square error is a, this one, the sum of square divided by 4 equal to this 36700 0.996, and residual also, this is a sum of square this 68206.515 divided by 45 1515. So this is, and this is a F statistics is the ratio of the, this is mean square error of mean square of regression divided by mean square error. This is F value. So we calculated through software. So we get a that p value 0.0000. This is highly significant. It says, now here is a, what does indicate this significant p value? Now here is a p value is a less than 0.05, less than 0.05. And in a slides I have shown you that null hypothesis h naught beta 1 equal to beta 2 equal to beta k equal to 0. That, and alternative hypothesis is a, this all betas are not 0, or perhaps all 0. So here is a, what does indicate? This is p value is less than 0.05. It indicates that this null hypothesis may be rejected. Null hypothesis may be rejected. So this ANOVA table indicates that there is at least one variable. There is at least one variable is a present in your model. That variable predict the outcome variable, blood pressure, and that is a related, that outcome, that particular, at least there is a one variable is present in your model that is correlated with the blood pressure. This is it, that this ANOVA variable indicate this, but we don't know that which variable is significant. This is the main issue is here. So for that, see, the following table is given for checking the individual significance. So whether individual variable is a significant or not. Now you look at this coefficient table, you look at coefficient table, and that coefficient, because first ANOVA table, it gives only, if suppose here is a p value, suppose getting a in the table, in ANOVA table, if p value is getting greater than 0.05, then it indicates that none of the variables in a model making role to predict the outcome variable. All variables are insignificant. All variables are zero. There is a no effect with blood pressure. But this ANOVA table indicates that there is a at least one. Now, with the help of the second table, we can make judgment this which variable is significant. Because with the help of ANOVA table, we came to know this at least one variable is significant, or perhaps all significant, and this, with the help of this table, coefficient table, you just try to find out this particular individual variable is a making role or not to predict the blood pressure. Now here look at this age, you look at age, and you look at the p value is getting 0.644, which is a very greater than 0.05. The significant value is a p value is greater than 0.05. It indicates that age variable is not significant. Age variable is not correlated with blood pressure. Age is not effect. For this sample size data, obesity, see now second variable, obesity individual variable. So obesity variable here is a getting 0.0000. Now here obesity means this is a body mass index. If your body mass index is higher, so definitely this data shows that we can conclude that obesity, if you somebody is suffering from obesity or body mass index, higher body mass index, that could be a one risk factor of blood pressure. Means this obesity is correlated with a blood pressure. So this obesity is making role to predict the blood pressure. If you have obesity, so definitely uh, that person having uh, blood pressure. And you look sugar level, if your sugar level is fluctuating, sugar level, so but here sugar level, this p value is a 0.525. You look at the last column, significant column, you look at the significant column. In a significant column, the sugar level value, p value is showing 0.525, which is a very greater than 0.05. So it indicates that sugar level is not affecting on a blood pressure. And triglyceride also is getting 0.474 p value. It indicates also that a triglyceride also not a risk factor of blood pressure. This is not a risk factor of blood pressure. So here, see, now suppose see, this is a simple understanding. So first table, ANOVA table, it gives whether it is single or variables are significant, overall significant or not. So if it is a simple, if it is a this value is a p value, significant column value is a very less than 0.05, then it indicates that there is at least one variable significant, or perhaps all. But we don't know which variable is significant. Then you take help from this coefficient table, and you look at the this significant last column, and you will get information. This, see now some these methods also available. See, so now this is a four independent variables. Sometimes you may have a 10 variables, 15 variables. Um then the software has a facility. Some methods are here, which is called as a variable selection method. When you use these methods, so automatically the software automatically it will be exclude insignificant variables. It will show only significant variables in the model. So see, I would like to show you these variable selection methods. So under this regression, they have given this variable selection method. With the help of this variable selection method, we can um, directly calculate the important variable. See, this some methods are given. What we use now is the enter method is used. In a enter method, this it gives all the variables which are significant and insignificant variables. But when you use some other method, this stepwise remove, backward elimination, and forward selection method. So this, with the help of this method, we can calculate the important variable. So which variable is making role. From this all the method, this stepwise regression method is a very important actually. Forward selection method and backward elimination method, it has some drawbacks, because in forward selection method begins with a no variable in the equation initially. So we try to calculate the correlation between blood pressure and variables. And first we entered that variable which is highly correlated with the blood pressure. Then we enter. But here a drawback is this: once the variable is included in the model, we cannot exclude in the model. Once this variable is exclude from the model, we cannot include in the model. That is the drawback of forward selection method. But backward selection method, in a backward selection method, uh, begins with all variable in the equation, all variable in the equation. But here is also drawback is there. Once variable is included in the model, we cannot exclude. So this is, but but in a stepwise regression method is a it's a recommended method, stepwise regression method, then backward and forward selection method. Because in a stepwise regression method we use both forward and backward. First we use forward method, and we try to eliminate that variable with the help of backward elimination method. If these two variables, if first variable is enter model and second variable is enter in the model, if these two variables are sustaining together, it indicates that that variables are significant. So each and every steps that variables validity checks in a stepwise regression method, whether that particular variable is a, because what happens, some one variable included and other variable included. When you include some other variables, so some first few variables or maybe might be exclude from the model, because the these are four variables. If you have included some other variable, so this some other variables troubles that we can say existence of that other variables may be in trouble. So the stepwise regression method is a more recommended. So you just click over in stepwise, and you just click over, so you will get important variable directly. See here, now we have used that stepwise regression method, and each every step they have, see, now excluded. Then software directly excluded these three variables. See, in enter method we have seen age, sugar level, and triglyceride were insignificant. They have automatically excluded that variable from the model. Now your model is only this obesity is only significant. So your model is y equal to 9.00, 9.033, uh, 9.0, sorry, y equal to minus 62.615 plus 9.033 obesity, that would be your fitted model. So only one variable, this obesity is making role to predict the outcome variable y. This is here. Now, after fitting this model, now we got to know this only obesity is making role, and these other variables are not significant with blood pressure. So that's why this automatically the software excluded that variable from the model. Now see, now after fitting this model, you try to check your assumptions. Now how to check assumptions? Again, this go to the regression. So I told you these assumptions are whether this DW errors are independently distributed or not, then errors are normally distributed or not, and the errors have uh, constant or not. So here in linear, now see, here is a statistics. Here is a for a errors are independently distributed or not. Is a Durbin-Watson test is given. This you click on a Durbin-Watson test to check the residual whether independently distributed or not. This is, and you just continue here and then click on a plot. Now with the help of plot, you will get this to check normality whether this errors are normally distributed or not. So you take this Z, this is a standardized predicted values, standardized residual values. So these variables are already in the software. So this is a Z predicted, you drag in a X axis and residual on a Y axis like this, and click on a normal probability plot here. Continue and okay. See, so here you will get information about that assumptions. Now look at this. This is a QQ plot. This is normal probability plot. With the help of this normal probability plot, we can make judgment whether these errors are normally distributed or not. Now see, all the points are lie on a straight line. This is a little bit away from the straight line, but it is approximately normal. It is a approximately normal, so it follows normal distribution. This is, it follows normal distribution, and here is a Durbin. Sorry, here is a Durbin-Watson test also given. Here is a look at here. This is a model summary. This is a Durbin-Watson test. So Durbin-Watson test is a, getting 2.072. 2 point, and I told you if Durbin-Watson is a lies between 0 to 4, if Durbin-Watson is a approximate to 2, it indicates that uh, errors are independently distributed. Errors are independently distributed. Now you look at this statistics, Durbin-Watson statistics is getting 2.072. It's a approximate to 2. It's approximate to, you can consider as a 2 here. This, so it indicates that there is no there is errors are independently distributed. And to check the variance, see constant or not, variance constant or not, again you go to the this linear, or see this one graph is showing here, another graph. See here, this, with the help of this we can make judgment. This is, now see this graph, is there any you can observe this graph, there is no any particular pattern showing. It is a structureless graph. This is structureless graph. If this graph is showing some patterns like a funnel shape, funnel, funnel shape pattern, if this graph showing funnel shape pattern, now you look at this graph is not showing any funnel shape pattern or curvilinear pattern. uh, if this funnel shape or curvilinear pattern is showing in a graph, so that graphs indicates that your variances are not constant. But here is a graph shows structureless. So it indicates that your variances are constant. So if all the assumptions are satisfied, then it indicates that our model is very approximate to truthness. This very approximate to truthness. So, but this, see, models are just merely representation of the reality. We don't know what is the reality. Actually, this is a model changes sample to sample. If you have taken 100 sample size, your model would be changed. If you have taken 500 sample size, your model would be different. But if this, what you are taking sample size, 100 sample size or 500 sample size, for this sample size, your model is very approximate to truth. See, you increase the sample size, your model would be more approximate to truthness. This is, so in this way, we can use this multiple linear regression model and uh, now see, our objective is this to study the relationship between blood pressure and the risk factors, and what we are taking variable as a risk factor to check whether there is a correlated or not with blood pressure. So after applying, after using this multiple linear regression model technique, statistical technique, so we got to know and we came to conclusion this only obesity variable is making role to predict the uh, blood pressure. Only that obesity is correlated with the uh, that blood pressure of that sample size of that study population, what we have taken for study. This is, if you increase sample size, your answer would be something different. Some variable may be include or maybe exclude from the model. So always models are, I told you, that's why I just models are changes sample to sample. But in a research also, what we take sample size, and on the basis of their sample size, we come to conclusion, these variables are important and these variables are not important. So other student will come and will increase or decrease sample size, or some he will add some other variables to inspect or to do research more on that. So this answer would be something different. So with this, I would like to finish with this regression analysis concept. Definitely, uh, this will be helpful for your future research. Uh, okay, sir.
Okay, sir. Any questions from student side?
Hi, if any question, you can ask me. No question.
Yes, there are no questions. If you have a question, if question comes in future for the analysis, you just directly you can contact Gite sir. Gite sir is a part
Yes,
of
yes,
our
sure.
university. Sir, please share your number and email ID. If somebody needs, then they will.
Yes, yes. Yes, yes, definitely. You have this my number and email ID. You can share with them. So no problem.
Okay, okay, sir.
Uh,
Okay, then since last means from yesterday and today, we are listening Gite sir on various aspects of statistical data analysis, interpretation, different ways to see the data and all. So this will be helpful for you to analyze your data in during your research work. So with this as a From the on behalf of this pre-PhD coursework coordinator and director, I would like to thank